Hi everyone, I am so happy to be talking to you today. I just want to give you a little overview of some research I did last summer and this summer on the germination of our native Colorado seedlings. So I did my research thanks to Alex Crochet, who you guys all know. He allowed me to do this research by observing the seedlings he had planted in his greenhouses for Colorado Springs horticulture, since Alex is the Colorado Springs city horticulturist. I ended up making weekly observations of Alex's seedlings from around the beginning of June to the beginning of September, and all I did was I recorded the presence or absence of seedlings in each cell of the seed trace. So here we just have an example of some germinated blanket flower seedlings in one of the seed trays in Alex's greenhouse. You can see here that there was pretty high germination in the blanket flower seedlings. There are some cells that do not contain any germinated seeds, but overall the seedlings are healthy and they are doing well. Again, here we can see another example of some germinated seedlings. These are buffalo gourd in the seed tray, and these do not have quite as high of a germination rate as we saw with the blanket flower. But the seedlings that did germinate were very healthy, and they ended up growing to be quite big, and they were good plants. So now I just want to give you an overview of some of the results I saw with the plants that Alex decided to plant in his greenhouse. So here is the overall graph of all of the germination rates of the 42 species that Alex planted in his greenhouse and which I observed from June to September. You can see that there's definitely a wide range of different germination rates among all of the species. The highest you can see is Penstemon strictus, which had an overall germination rate of 100%. It was doing very well. And at the lowest, there's quite a few species that did not germinate at all. And there's quite a few potential reasons that they did not germinate. But overall, you can see that I would say Alex was quite successful in germinating his seedlings. So again, just for comparison, I wanted to show you all the germination rates of species that were treated before they were planted. In the case of species like yucca and penstemon, you can see that there is sometimes not a huge difference between the germination rates of species that are treated with something like soaking and those that aren't treated. Yucca did not have a significant difference between the germination rates of the seedlings that were treated or weren't treated. Penstemon did not, but some of the species in the top row here, as you can see, did have significant differences. Echinacea, for example, when it was treated with cold moist stratification before it was planted in the greenhouse, showed a significant difference in germination rate. It climbed from around 0.25 to 0.75. So that certainly was effective in increasing its germination rate. So around 50% of all 42 species in the greenhouse ended up germinating. That was the mean germination rate for all of the species, and I'd say that's a good number. I think that we could all agree that given that these are native seedlings, which are often said to be difficult to grow in greenhouse conditions, 50% is very good, especially as a starting point. And when you consider that not all of the species germinated, if you just look at the species that did germinate, you would see that 62% was the mean germination rate for the species that did germinate. So, as I mentioned before, Penstemon strictus, which we also call Rocky Mountain penstemon, actually had a 100% germination rate for its seeds that were treated with cold moist stratification. The number of seedlings that germinated in the groups that were not treated with cold moist stratification was slightly lower, but still very high. So it's possible that in the future we might want to look more into using Penstemon strictus in horticulture, restoration, those kinds of contexts, because we were very successful in germinating this plant from seed. So there were 3 species that showed germination proportions that were greater than or equal to 0.9 or 90%. That was Penstemon strictus. We also had black-eyed Susan and upright prairie coneflower. Those all had high germination rates. So just like with Penstemon strictus, I think it would be potentially useful for us to consider using black-eyed Susan and prairie coneflower in future horticulture and restoration contexts. So just some highlights of my results were that I found there were 8 species in total that also showed high germination proportions that were greater than 0.8. Of the species that I haven't mentioned, those include echinacea, purple prairie coneflower, evening primrose, blanket flower, and yarrow. There were 5 species that actually had very low germination rates of less than 0.2. Those included buffalo gourd, golden columbine, four-winged saltbrush, three-leaf sumac, and mountain mahogany. I have done some research into why those species might have had such low germination rates. You can find some of my potential explanations in my paper, but I think there is certainly potential in the future to increase their germination rates so they are not so low. There were also another 6 species that had no germination at all, which included Palmer penstemon, chokecherry, Missouri iris, airleaf balsam root, Rocky Mountain bee plant, and snowberry. And again, I've done some research into why those plants may not have germinated, and there's some varying explanations, but hopefully in the future we'll be able to produce some germination in those plants and grow them successfully. So what I was able to conclude from this research was essentially that Alex Crochet and Colorado Springs horticulture were quite successful in growing these native plants. And part of the reason, as you've already heard from Kenner, was that Alex designed his own soil mix, and he was able to very closely mimic the soils in which many of our native plants grow. Because our plants have adapted and evolved to grow in those soils, naturally we are seeing that there is a high germination in soils like that, and so that is something that we should certainly continue to do in the future when we are trying to germinate native seeds. It is often, I think, discussed among horticulturists that it is difficult to grow native plants from seed because they don't germinate or for various other reasons, and I think that we found if they are difficult to grow, it is often because we are growing them wrong and not necessarily because they are intrinsically difficult to grow. So I think in the future we can certainly grow native plants reliably in greenhouses for use in projects involving horticulture and restoration, as long as we properly adapt our methods of germinating and growing those seeds. So I've also included some photos of the germinated seedlings here for you. So if you'd like to see what these plants look like when they're germinating, you will be able to see that. These tables are also included at the end of my paper, so if you'd like to look at those, you can. I found it interesting kind of just to take a look at the differences between all of the seedlings and their different characteristics, and to see how those characteristics mimic what they end up looking like once they're full-grown plants. So if you have any questions, I think you should be able to give your questions to CoNPS, and I will do my best to answer when I can. Thank you.